Welcome back. Today we're going to discuss about LaTeX files. So since we've learned how to write equations in a block, here we want to apply them into a LaTeX file, like as shown here. So we want to learn first about the LaTeX compilation structure. You have a .text file which holds your document, and LaTeX will be able to compile the text file into a PDF document, which is shown on the right. So now we're thinking about the most basic structures of a LaTeX file. So in the start, we'll have to set up the document. In other words, we're going to set the document class, and here the example uses an article with font size 10. And then we're going to import the necessary packages. So here for simplicity, I've just give two examples. Using the \use package, you'll be able to include here the AMS symbols and AMS math, which are some necessary symbols for math documents. And then you would want to actually provide the title information. This is actually optional. If you don't use the make title later on, you don't have to have a title and author. But for most cases, it's good that you put the title, author, and date here. And if you don't want to include the date, it will use the current date, the date that you use for compilation. Then you would want to have the document environment to hold all the things you want to have. For example, here I first used / make title, so you'll be able to see the title, author, and date showing up on the top. And then I put just a hello world, and you can see the hello world is showing up on the document on the right. And then you close the environment by / end document. Just note that you need to put everything you want to be displayed inside the begin document and end document environment, so it will be shown on the PDF document after compilation. Right, and then we're going to discuss about some packages that you might find useful. So first, there are the AMS fonts, AMS math, and AMS symbol, and AMS theorems. So these will be able to do will help you to deal with some math stuffs. For instance, having some math fonts, some extra math symbols, actually like some mathematical environments like proofs or theorems or so. Then you can use, for instance, the color package to deal with colors. You have fancy header to deal with fancier headers. And for instance, here for the geometry with margin equals to 1 inch. This sets the margin size to be 1 inch. Speaking of the fancy header package, as long as you include that package, you'll be able to use the header and footer. So for instance, here I set my left head, center head, right head, and seafood. So in those cases, you'll be able to customize what will be displayed on the header and footer for each page. Specifically, by default, the seafood will be the page number, and / the page will be the command for showing the page number. And right, and you can cover them by what you want to be displayed on your document. And of course, if you're dealing with mathematics, sometimes it would be helpful for you to include some math operators by using the new command and / declare math operator. So for instance, here I've tried to declare some math operators so that, for instance, for the first one, the Blackboard bold font of R, which represents the real numbers. When I use the new command \r with \mathbb of R, this will help me to actually input \r to represent the whole \mathbb R. And in this case, it will be able to help me, especially if you're in a math setting that you're typing a lot of real numbers, complex numbers, integers or so. This will help you to type less while you're doing those documentation. And this is, of course, what you want to set your command with the symbols, and it depends on what you would want to do and your own habits. And having these set it up will help you to type way faster, especially if you're doing live texting. And of course, for some operators like the span, image, or range, you'll be able to declare them as operators first, and in that case, you'll be able to have the Roman font rather than the italic font when they're showing up in equations or so. Then in our example, we've shown some equations, some in text, some math embedded in text, and also some more complicated equations. So for these environments, they are included by LaTeX already. And for instance, for the first time we were trying to have the sine square of x plus cosine squared of x equals to 1, this can be put between an equation environment. Note that the equation environment will only allow you to do a single line, and here I use the equation star environment, so it won't have the label in the end. If you get rid of the star, it will be automated numbered by a label. And then for the next line, I try to put my mathematical equation inside my line rather than having a center like the equation environment. In those cases, I use a single $sign on the left and on the right. For instance, I have x in \r, and recall that \r, it was defined in the previous slide that it represents \mathbb of r, and in this case I'll be able to use this to compile the Blackboard font of r quickly. And similarly, I do y in the image of f, and in that case IM got defined in the previous slide as well. And also, when you want to have those equations that are more complicated, in other words, you want to have it in multiple lines, you can think of the align environment. For the align environment, everything will be aligned using the ampersand sign. So everything before the ampersand sign will be always before everything that's after the ampersand line. And if you have multiple ampersands, you can think of the ampersands as aligned at that place, and everything on the left of it will be on the left of it, everything on the right of it will be on the right of it. We're having multiple ampersands, it will be a little bit more complicated, but you can try to put in more ampersands to get the right alignment. And note that 2 backslashes will allow you to do a new line. So in these cases, you'll be able to type equations of multiple lines. And this concludes this program, and here there's no more practice questions. You can try to type your next homework with LaTeX, and thank you for watching this series of LaTeX Foundation sessions.